20s. Hopefully you guys had a little bit of a break there while we were registering kids for next year. We are now moving into the stoichiometry unit. So we have 2 units left. Stoichiometry is a fairly big unit that requires you to use a lot of the stuff from Science 10 chemistry, and that's writing reactions. So for the first 3 days, we are just going to be practicing writing reactions. I don't want to freak anybody out, but this unit is a unit that you need for Chemistry 30. So we are going to go slow, and some of you guys are going to get this right away. It's going to be super easy because you found this stuff really easy in Science 10. Some of you, I know, really struggled with this in Science 10 because there's a whole bunch of rules. So I'm going to go pretty slow, and I'm going to have a couple of practice assignments that you can do to see if you're on the right track. All right. Now, the start of this unit involves writing reactions, and for most of stoichiometry, we're going to be using reactions that are called non-ionic reactions. So they are just straight up normal reactions. They have a special name, non-ionic reactions, which means that they do not show broken up or dissociated substances. Okay. Now, with IB, I cover all of this in about 2 days, but we're going to take an extra day, so that means everybody has a lot of chance to look at it. These are the reactions you guys did in Science 10, the single replacement, double replacement, formation, decomposition, burning, and neutralization reactions, the 6 reaction types. And you have to know how to write them to do the math in this unit. So that's why these steps are really critical. So we're just going to, today's lesson is I'm just going to go through the different types of reactions and go over the rules, because there's a lot of rules that maybe you forgot about. Okay. So reaction 1, we're going to do the non-ionic reaction for sulfur and phosphorus combined to form sulfur diphosphide. So we have 2 elements forming a compound. So if you care, this is a formation reaction. Okay? Sulfur plus phosphorus combined to form sulfur diphosphide. Now, I've missed a whole bunch of stuff. This becomes, in Chem 20 and Chem 30, the nitty-gritty. Like, you have to know all the little ins and outs. When sulfur's by itself, it's S8. When phosphorus is by itself, it's P4. And these are both solids. We also have to include the states. If you forget the states in this unit, that is a marked deduction. Okay? So there's some little things that become big things, like the states are very important. And it doesn't tell us the state of sulfur diphosphide, but anyways, okay. So we do have to balance this because we don't have the same number of atoms on either side. We have 8 atoms of sulfur, but only 1 right there. So we need to put an 8 right there. Now that 8 means everything behind it is 8, which means 8 times 2, 16. So I need to put a 4 in front of phosphorus. You may remember this now. It's probably coming back to you. Writing reactions was a huge part of Science 10 in chemistry. Okay, next one. Water decomposes into its elements. So this is a decomp. All right, so water into its elements. What is water made of? Hydrogen and oxygen. Now, I'm forgetting some stuff. Hydrogen and oxygen by themselves as elements, not when they're connected to other stuff, just by themselves, are 2s. And my class, I taught everybody the acronym Hofbrinkel because I hate clowns. I thought of this clown named Hofbrinkel, and these are all 2s. when they're by themselves. And then phosphorus is 4 and sulfur is 8. Okay. Water at room temperature is a liquid. Hydrogen is a gas. Oxygen's a gas. Okay. Now we have to balance this. The hydrogens are good, but the oxygens aren't. We have 2 right here, 1 right there. We need a 2 to balance out the oxygens. Now that makes 2 times 2 of hydrogen. Do I put a 4 there? No, because that 4 means 8. 4 times 2 is 8. So I have to make sure that's balanced as a 2. Now I have this balanced. Okay, next one. Copper 2 nitration. Copper 2 nitrate solution reacts with aluminum metal. Okay, so here we have a compound, copper and nitrate. That's an ionic compound. And it's reacting with aluminum metal, which is an element. So this is a single replacement reaction. All right, so we'll go copper and nitrate. Copper being 2 plus and nitrate ion being 1 negative, we need 2 nitrates for every copper. So if you remember back to Science 10, when you have more than one polyatomic, they have to be in brackets. Okay? And it says that's a solution, so it's aqueous. Remember that from Science 10? If something's a solution, it's aqueous. It's reacting with aluminum metal. Now, aluminum by itself is just aluminum. It's only the non-metals that you have to worry about that exist in 2s, 4s, or sulfur 8. So the aluminum is going to kick out the copper. Like switches with like. So the aluminum is going to kick out the copper, and the copper is going to be by itself. Okay. Now, we've been spending a lot of time talking about ions. When copper is by itself, it will be an ion. Unless otherwise stated, when a metal, remember this was a metal, metals are solid, metals don't have charges. When a metal replaces a substance, it will make itself a solid as well. Okay. And then the aluminum is going to go with the nitrate. Now, aluminum's 3 plus. So when we balance out aluminum nitrate, we need 3 nitrates. Now, the other thing is we have to check our solubility table, because if we started with an aqueous solution here, we have to check to see if this is going to be soluble. Nitrates are always soluble. Now, I'm not quite done. We have to balance this. We have the same number of aluminums and coppers, but our nitrates are messed up. If you look, we have 3 groups of nitrates here to 2 groups of nitrates here. Let's Uno reverse that. So let's put a 3 here to make 6 and a 2 here to make 6. Then now we have the same number of nitrates. So I just moved that 3 to here. It's kind of a sneaky trick. Okay. And then 2 and 3. Okay. All right. Continuing. A solution of silver nitrate is reacted with a solution of sodium carbonate. Okay. Silver is +1, nitrate's 1 negative. So that's an easy one to balance. It's 1 and 1. Sodium is +1, carbonate is 2 negative. So we need 2 sodiums for every carbonate. There, and that's aqueous. Okay, so that's our starting point. Let's make that a little smaller. This is a double replacement because we have 2 compounds. So the metals are going to switch. The silver is going to go and kick out the sodium. So we wind up with sodium nitrate. Sodium's 1 plus, nitrate's 1 negative, and silver is 1 plus, but carbonate is 2 negative. So we need 2 silvers for every carbonate. Let's check our solubility table. This is a solid. That is aqueous. Carbonate is a solid with silver. Balancing this, it looks like we need to put a 2 there and a 2 there. Now we're balanced. Okay, 2 silvers, 2 silvers, 2 nitrates, 2 nitrates, 2 sodiums, 2 sodiums. Butane burns. This is a carbohydrate combustion. And whenever you burn something, you need to add oxygen to it, and it makes carbon dioxide and water. And both of those are gases. It's so hot, it makes carbon dioxide and water. And if you had me for IB, we balance carbohydrate combustions using the acronym CHO. Butane is a carbohydrate. How do I know that? Well, I've got all these memorized. But if you check page 4 and 5 in your data booklet, it gives you the common names of a bunch of different stuff. And butane is C4H10. A carbohydrate means that you have hydrogens and carbons together. You don't have any metals. That's a hydrocarbon. Okay? Butane, I think, is a liquid. No, it's a gas. My bad. It's a gas in your data booklet. And when we burn this, we need to have oxygen. This is its own special reaction. It will make carbon dioxide and water vapor. And we're going to balance this with CHO. So carbons first. We've got 4 there, 4 there. Okay, hydrogens next. We've got 10 there, 5. Okay, now we have to balance the oxygens. Okay, so 4 times 2 is 8. And then we've got 5 there. So that's 13. 13 oxygens. Now you have a choice. When you wind up with an odd, like you can't, how do you make this? How do you make 13 out of like a multiple of 2? Well, you can use a decimal. You can go 6.5. That's fine. What other teachers maybe told you to do is when you wound up with a odd number, we can make this even at 26 by going back and doubling everything. So that's another thing. And then now we have 26, so this becomes 13. 6.5 is just half of 13. You can even be crazy cool and go 13 over 2. Ooh. So that's balancing that one. Okay. Always makes carbon dioxide and water. Balance with CHO. Don't forget oxygen as a reactant. Okay, the last of the reactions is sulfuric acid and sodium hydroxide solution combined to neutralize. These are neutralization reactions. Now, neutralization reactions are fancy double replacements. Sometimes they're a little bit trickier to wrap your head around. Okay? Because we have to pretend that hydrogen is a metal. Every hydrogen ion is +1. So the way you can do neutralizations is pretend that the hydrogen and the sodium are going to switch places. So the sodium kicks out the hydrogen and replaces itself over there. Now, another thing that's made in a neutralization reaction is water. Okay? And water, if you write it HOH, because the hydrogen's going to replace the sodium, water's H2O, but if you write HOH, you can separate that. You have a hydroxide and a hydrogen. Okay? And then the sodium is going to connect with the sulfate. Sulfate's 2 negative, so we need 2 of those. Now we're not quite balanced because if we look, we have only 1 sodium here but 2 there, so we need to double this. If we double this, now we have 2 hydroxides. By writing water, HOH, now we can see we have 2 hydrogens and 2 hydroxides. And look, we have 2 hydrogens and 2 hydroxides. Okay. This is the crash course of the 6 different types of reactions from Science 10. I'm going to get you guys today to practice 6 different reactions from Science 10. This is not going to be for hand-in. I'm going to have a little practice and then a key. So if you're really confident that you know what you're doing, try it even, see how you do. If you're having some struggles, I know it's tough. Online learning with this is really tough because you can't come in for flex and get extra help from me. But you need to advocate for yourself in this because we are going to be moving quickly where if you're not doing this part right, you will just get the whole rest of the math wrong. And it's really unfortunate. Okay? So make sure you ask ZDog or myself for help. And we will do our best this week to maybe do extra Google Meets and go make extra examples and extra questions for the people that need it. But we won't know that you need help if you don't say that. Okay, so please advocate for yourself. Okay, we'll get through this together, guys.